say I want to count in my list the number 13. So there I get 2. And it turns out that instead of counting 13, I can count something much more flexible that's called a pattern. So as an example, let me call it x underscore. So this should remind you of when we talked about functions, where I said f bracket x underscore, and you're supposed to think of that as anything, call it x. So why did counting x underscore give me 7? Well, it's because it's saying count anything. Would have been the exact same if I had just counted underscore. So why do I get 7? That's because there are 7 entries inside this list. And the way the patterns work is, well, why did I care about calling it x? Well, here's an example. Say I want to count all x's, and then think of this front slash followed by semicolon. Think of that as the phrase such that. So I want to count all x such that, and then for an easy one, do 2 equal signs 13. So this is just a really complicated way of saying count 13. Count all x's such that x is equal to 13, and there are 2 of them. 1, 2. But that should give you an idea of how to do some more complicated things. For example, let's count all x's such that x is greater than 10. That gave me 3. And what are the 3? These are the 3 that are greater than or equal, that are greater than 10. If I want to do greater than or equal to, then I get 5, because there are these 4, and then also this one. And there's a huge amount of flexibility for this. For example, let me change the name to y, just to show you that I can name it anything I want. Let's count all y such that y is odd. So the thing that comes after this front slash semicolon, it's always going to be some true-false thing. Here the true-false question is true or false, y is odd. So this is saying count how many y's there are such that y is odd. And the answer is 1, 2, 3, 4 of them. If I had done even, I would do that with even q. It says there are 3 that are even. I could do prime q. That's saying how many of these are prime. 3, 13, 23, and 13. Those are the prime ones. And just like with iterators, how we saw them showing up again and again, for example, in table, or in the do loop, or in sum, or in product, these patterns, like this, those show up again and again also. For example, instead of doing count, I could do cases. Keeps the exact same syntax, but now instead of telling me how many are there, now it tells me what are they. Another one I can do is position. Let's do position in my list of how about a such that a is even. And so what is that telling me? It's telling me that in position 2, 6, and 7, I have an even number. Here's position 2, here's position 6, here's position 7.